Hello everyone, I'm back. My name is Rebanding Flores and welcome back to my YouTube channel. For today, we will discuss triple integrals in cylindrical coordinates. In this, we obtain cylindrical coordinates for space by combining polar coordinates r and theta in the xy plane with the usual z-axis. This assigns every point in space one or more coordinates triples of the form r theta z as shown in figure 2. Take a look with this figure. We have the x, y, and z and the following coordinates of r, theta, and z. Points rather. So this is the definition of cylindrical coordinates. Represents a point P in space by ordered triples r, theta, z, in which the quantity of r and theta are polar coordinates for the vertical projections of P on xy plane. Z, on the other hand, is the rectangular vertical coordinates. The rectangular xyz and cylindrical coordinates are related by the usual equations as follows. So x is equal to r cosine theta, y is equal to r sine theta, and z is equal to z. We have this r squared is equal to x squared plus y squared. Tan theta is equal to y all over x. So this is the formula for triple integral in cylindrical coordinates. We have this triple integrals, the function of x, y, and z dv. So is equal to the triple integrals of the function r cosine theta, r sine theta, and z. dz is evaluated from r z sub 1 r and theta to z sub 2 r and theta. For dr, evaluated from h sub 1, which is theta, and h sub 2, which is theta also, and the d theta, which is evaluated from a to alpha to beta. Where volume element in cylindrical coordinates is given by dv is equal to r dz dr and d theta. So we have this example. Evaluate the triple integral of y dv, where E is the region that lies below the plane z is equal to x plus 2, above the xy plane, and between the cylinders x squared plus y squared is equal to 1, and x squared plus y squared is equal to 4. You observe we have this first step. We need to identify the given and write it in a triple integral form. So we came up with the triple integral of the function r sine theta, r dz dr theta, evaluated from, for dz we have 0 to r cosine theta plus 2. For dr we have 1 to 2. For d theta we have these limits of 0 to 2 pi. And then we first evaluated the the dz. So we came up with the two remaining integrals of r squared sine theta, quantity of r cosine theta plus 2 theta, dr d theta. Next is to combine and or simplify. So we came up with the two remaining two remaining integral rather, 1 over 2 r cubed sine 2 theta plus 2 r squared sine theta dr d theta. Next is to evaluate the dr with the particular limits of 1 to 2. So we came up with the integral of 1 minus 8 r raised to the power 4 sine 2 theta plus 2 all over 3 r cubed sine theta, evaluated from 1 to 2 d theta, 0 to 3 to 2 pi. Next is simplify. So we came up with, in simplifying, we came up with substituting the value of 1 and 2 to the given. So we came up with the integral of 15 over 8 sine 2 theta plus 14 all over 3 sine theta d theta, particular limits of 2 to 2 pi. Next is to integrate the particular given to the remaining integral. So we came up with quantity of negative 15 over 16 cosine 2 theta minus 14 over 3 cosine theta, evaluated from 0 to 2 pi, and that would be equal to 0. And that would be all in evaluating the cylindrical coordinates in triple integral. Thank you.